what you see on screen is the typical plain vanilla enterprise composite network model, sometimes called the enterprise network infrastructure. And let's talk you through the nuances of this so we understand how our routing solution solves the challenge of interconnectivity at layer 3 for these different devices, okay? So what's going on here? Well, let's start where our end users are plugged into. End users plug into VLANs that live at the access layer of our topology. We might have IP phones that live here. The subnets for wireless connectivity are going to terminate here as well. Those go up to the building distribution layer. Now, those are multi-layer switches, which means they're fully capable routers. Think of them as routers, more so than thinking of them as switches. Sure, they can trunk and do VLANs and spanning tree, but what really makes them shine is routing capabilities. And that's where our subnets at the access layer are terminated. These function as the default gateways for clients. And then we route through the rest of the infrastructure. We have a backbone that allows for lots of these distribution blocks to live. This would be a building block, this building distribution and building access. Call that a building block. That's the technical term. And if we need more scalability, we'll create more of these building blocks and attach them to the core or the backbone. And usually when it's the campus core, we call it the backbone, but it is okay to call it the core as well. And then we have the glue to the outside world, whether that be the internet, WAN connectivity, and that's going to be accomplished by the edge distribution module. And then that gives us some choices. Are we going to send this just out to the internet? Sometimes we have connectivity to e-commerce. We don't see that here. Or we go to WAN connectivity. So we're talking maybe some classic stuff. You could even have dial-up. But here we're going to see things like frame relay, traditional WAN connectivity. And we have some solutions to go on top of that to make it better for our routing solution. We'll talk about that. And so we connect up through the internet to the other sites that are out there. Now what's important is we have to be able to advertise the subnets from the remote locations to the local and vice versa. So I want you to think about this. Let's say I got a subnet that lives at the building access, and we'll say that's VLAN 35. So I have that subnet. Maybe I have a few more subnets. We'll add that to the equation. Those could live at the access layer. Our routing protocol is going to need to advertise those through the topology. Now, in fact, I've drawn the arrow in the wrong place. Those networks are originally emanated by the attaching layer 3 device. The device that is locally connected, that has a connected route to those subnets, needs to initiate it. Then, through the wonders of these dynamic routing protocols, which are just a language to advertise these subnets, that's going to course through the veins of your network and go to all the other different devices that are out there and be advertised over the WAN, assuming we want that. That's the sort of challenge that we're going to have. Now, what about the internet? I didn't really do a lot of advertisements over the internet. And the reason why I'm not doing that is because what kind of networks are these? Are they public or private networks? These are public networks, are they not? And because they're, did I just throw you for a loop? They're private networks. The 10 space, 172.16 through 172.31 and 192.168, those are private networks. Okay. So because we've got these private networks, they in fact should not and cannot be advertised to the internet. That's the realm of another kind of routing protocol we'll talk about, EGPs, all of these advertisements that you see here, those would be done with an interior gateway protocol, which is the bulk of our focus, but certainly we're not solely focused on interior gateway protocols. So we have to understand our network. We have to understand, hey, I've got private networks. Those can't be advertised to the internet. They, in fact, would be filtered. And due to the nature of private networks, we wouldn't want that to happen anyways. We would not want to advertise them to the internet. So this is the sort of routing thought process that we would apply to our own infrastructure. Your topology may be different, might be a lot more complicated, but this should give you the paradigm and allow you to mold and manipulate the routing protocols that we're going to teach you to fit your needs. And that's really what it's all about.